Okay, good afternoon, student. Let's start today's class. We'll start with user defined data type. Basically, there are two types of data types. We can say that one is called built-in, which is already defined to the compiler, such as int, float, char, like this. Now, suppose I want to represent something which is called a complex number. Then we know that complex number not a single entity. It is consisting of two entities. One is called real part, another is called imaginary part. Okay. Similarly, if I say point in coordinate geometry, how to represent it? We need x coordinate, we need y coordinate. If it is a 2D, if it is a 3D, we need z coordinate. Similarly, if I want to represent a student, again, it is not a single entity. It has many parts or fields or attributes like name, his roll number, then other information also. So this type of things like complex number, point in coordinate geometry, or student information, if you want to represent them in a programming language, then it is very difficult to create separate built-in data for them. Yes, we can create. How? Suppose for complex number, we are using int x1, sorry, better use it as a r1, r2, I1, I2, like this. Okay. Now R1 is the representing first complex number real part, I1 first complex number imaginary part. But in this way, if I want to represent many different values or many different complex numbers, then better we go for array. One array to represent the real parts of all the complex number and another array to represent the imaginary parts of the all of the complex numbers. Now it becomes very difficult to make a synchronization between real part and imaginary part. Which real part and which imaginary part are belongs to one particular number, that becomes very difficult when we are trying to access those elements. That's why we go for built-in data type. Instead of going for built-in data type, we will go for user-defined data type. So user-defined data type means you are declaring your data, which is obviously from this built-in data, and you are creating for your own purposes. Such same like your user-defined function, where you are creating your own function for your own purpose. Yeah, similarly, for your own requirement, you are creating your own data type. And to do this in C language, there are three different things. One is structure, another is union, and another is enum, enumerated data type. These three things are basically used to represent your user defined data type. So why we are going to represent user defined data type? Because in some entities, we are not able to represent them with a single information. To represent them, we need more than one information, such like complex number or student information. So if I want to represent those things, it is very difficult to implement them using built-in data. Because for built-in data, we have to create separate built-in variables for separate uh, information representation. But there is no synchronization between two different fields of a particular information. Suppose complex number. There is a two fields. One is real part, one is imaginary part. Field means you can say attributes. So to represent those two attributes using built-in data, we can do it like this, but it becomes very difficult to synchronize. Means R1 and I1 belongs to same complex number, or R1 and I2 belongs to same complex number. That is very difficult to synchronize. Means for a new user or who have no idea about the program, he has to understand what is the meaning of R1, R2 like this. Clear? That's why we are going to represent some own user defined data type, which is nothing but obviously a combination of different built-in data types. And how we can do it in C language? In C language, there are structure, union, and enum. These are the three different keywords used to represent our different user-defined data types. Okay, so first we will see structure. You already know this. So how to define structure? The keyword struct. Then you can give any name. Suppose I am giving a name complex to represent complex number. Then each complex number having two different uh, attributes. One is real part, so integer real, and integer imaginary I. These are the two things. Then I have to use a semicolon. Now remember, this is only the declaration. This is only the declaration. So for declaration, no memory will be occupied. No memory is occupied. Okay. When it will occupy some memory, if I define any variable of this type. How to define any variable of this type? To define a variable of this type, first I have to write the name of the user defined data type. Remember, this is the name of the user defined data type, struct complex. Not only complex, struct complex is the new user defined data type. So this is the new user defined data type. Correct? Now, so this is the data type. Just like suppose T is a general data type, T is a general data type, then I will declare a variable like T. Similarly, this is the data type struct complex. Then I am using a variable like C1, C2, semicolon. So for the structure complex type data or data type, we have declared two variables, C1 and C2. Now, when I am giving the variable names, means I am using some variable names, then only some memory space will be allocated in the memory. Okay. Now the picture of the memory will be like this. First, this one is C1 variable. Then the next one is the C2 variable. Okay. In C1, there are two parts. One is called R and I. Similarly, in C2, there are two parts. One is called R, another is called I. Very clear? So each and every complex number having its own entity, own representation. See, for this C1, the R and I are in adjacent location. For this C2, R and I are in adjacent location. But if you create an array of real numbers, an array of integers, the picture will be like this. This is for all the R1s, all the real parts. So this is R array, 0, 1, 2, 3, 4. Then there will be another I array. Suppose after this. This is I array, 0, 1, 2, 3, 4, like this. But there is no adjacent, means adjacent position for a particular R and I. If you define using built-in data and array. Logic clear? But here you can see that all the elements, all the properties of a particular element, complex number, are in adjacent position. So it becomes very easy to access those elements. Now you can create a array of structure also, struct complex, then C of 5. It means I have declared an array of 5 complex numbers like this. Like this. Each, and so this is C of 0, 1, 2, 3, 4. This is each and every number having two parts, real part, imaginary part, real part, imaginary part, real part, like this. So see, all the elements, all the properties of a particular complex number are in adjacent position. So it becomes very easy to access them or visualize them. That is the advantage of declaring your own user-defined data type. Okay. Now the next thing is how to access. See, both C1 and C2 having R. Then which R you want to access? If you want to access C1's R, then you have to write it C1 dot R. So a new operator dot in coming in. So remember, dot operator, this dot operator only use, this operator only use to access structure members using structure variables. Similarly for union also. And the same concept is used in class. So structure and class, if it is class is C++, then structure and class having a almost same structure. The only difference is by default structure variables are public and the class variables are by default private. That is the difference. If you ever learn C++, then you can understand those things. So how to access each and every member? First the member name, variable name, then the member name. Now these things are also called members. Okay, so these are the members of a structure. Okay, so it becomes very easy to access now. So you can easily access those elements in the structure. Okay, then another interesting thing which is very important in case of our data structure, that is structure pointer. Now what do you mean by structure pointer? Structure pointer means a pointer which is pointing to a structure, a pointer which is pointing to a structure, that is called structure pointer. Okay, so suppose in the previous case I have declared a pointer like structure type struct complex, say star P. So P is a structure type pointer. Okay, it means there is a complex number like this C1. Okay, it has two parts, one is R, another is I. Okay, now this pointer P is assigned in such a way that it can point to this complex number. So how can I perform? So initially, suppose this is having address 200, this is having 300. Initially it has some garbage value, white pointer. So you can initialize it with null. That will be a better option or choice. initialize it with null, and if you initialize it with null, the picture becomes like this. This is called ground. So in electrical physics, in physics, you have learned this, that ground means you are making this thing zero. Okay, so null means it is pointing to nothing, and in pictorial representation it will be like this. Okay, now if I write it P equal to ampersand C1, it means the address of C1, that is 200, now is assigned into P. So this grounding information will be gone, correct? So now it becomes, sorry, so this grounding information is gone. Now it becomes P, it's giving some, I think I have to restart. Okay, no, sorry. So P, initially P was null. So now P is having 200. So now P is pointing to C. Okay. Now what is the use of pointer? Using this pointer P, I want to access R and R. Now if I want to access R and I using C, it will be like this, C1.R and C1.I, correct? Now how to get from P, how we can get C? If I perform star in both sides, then it becomes star P is equal to C1. Correct? This we have already seen this. So instead of using C1, if I want to access using star P, how to write this statement? This statement will be like this, star P, because it is equal to C1, then dot R. Okay? Then dot R, star P dot I. Now see, there are two operators. One is this dot operator, another is star operator. Okay, now this operator is having a precedence, and this dot operator having higher precedence than the star. So what will happen in this case? It will be executed like this. First this operation, then the star on it. But this is a wrong concept, because first you have to perform the star, then I have to access this. So this one is a correct syntax for accessing any structure member using structure pointer. So how to access using structure pointer? So bracket, so I'm giving precedence to this, then dot R, or star P bracket, then dot I. Now see, in this case, to access structure members using structure pointer, we have to use star, bracket, dot, all those three different operators. So that's why C has implemented another new operator which is called arrow operator. Arrow operator. Now the concept of arrow operator is how to create arrow operator: minus, then greater than. Remember this. This is not an simple arrow in your keyboard. It is created by minus, then greater than symbol. Now this is called arrow operator. Now instead of writing it like this, we can directly write it like this, P arrow R. Now you can understand what is the meaning of arrow. Arrow is pointer. So P is pointing to R, then P is pointing to I. So where we can use arrow operator? Remember, to access members, to access structure members using structure pointer. Only in this case you can use this arrow operator. So this is very simple to implement. P arrow R, P arrow I. So this is called structure pointer. Okay, logic clear? Now the next thing, we will go for union. What is union? You already know that union and structure having a basic difference. In case of structure, all the members have its own identity, means all the members having its own memory space. But in case of union, all the members could not get its own identity or memory space. Only the member having the highest memory space utilized will be allocated in the memory space. So why we should use union? The question number one, why union? The answer is, if there is a shortage of memory, okay, then we can go for union. And another thing that is very interesting means the application area. So if there is anything that is, means you can say options, different options are there, and you have to choose only one. Different options are there, you have to choose only one. In those type of things, we try to implement using union. So for example, simple example is, suppose there are given subject choices. So you have to select only one choice. So there is maths, there is chemistry, there is physics. Among all this, you have to choose, finally, you have to choose only one. Or you have to choose the gender, male, female, which one? Ultimately, you have to select only one. So what this type of things, which are called options, there are different options. Ultimately, you have to choose only one. In those cases, we go for union. Why? Because if I declare all these different members in a structure, all will get some memory space. But ultimately, only one will be allocated, or only one will be initialized. Others will be wastage of memory. That's why in those cases, options type cases, or if there is a shortage of memory, then we will go for union. Okay. Now, the declaration of union is same as our, so suppose it is option, subject. So there are, say, different subject options like integer, maths, chemistry, physics. Among this, you have to choose only one. Okay. So since you are choosing only one, so no need to allocate memory for all the elements. Because if you, instead of union, if you declare it as a structure, it will allocate, since both are all the elements, all the properties are in integer form, so it will allocate 6. But since it is union, so it will only allocate 2. So when there is a shortage of memory, then better go for union. Okay. Or of this type of things where the things is optional, or there is a choice, or there is an option, then better go for union. Okay. Now, in case of union, the same memory location, suppose for this thing, same memory location, 2 bytes will be utilized by all the members, maths, chemistry, physics. Okay. So there is one problem in case of union. The problem is you cannot access all the members simultaneously. In case of structure, you can access all the members simultaneously because they have their own identity, own memory space. But in case of union, there is a single memory space, basically or generally, for which one having the highest memory requirement. Why? Because in highest memory requirement, you can easily put the smaller one. That's why the highest memory requirement variable or property is assigned with some memory space. So for example, if I write an union like this, union, say A, then other things are same. After this declaration, you have to declare some variables, then you have to access those elements using dot operator. Those are same like as structure. So in case of union, if I declare a variable float f, then a integer a, say 2, and then character, say ch5. So for which it will allocate the memory, since this one only need 4 bytes, this one 2, so integer 2 is 4, and this one 5 characters, character is 1, so 5. So ultimately only for this variable means 5 bytes memory will be allocated. This is not for only for this variable, this memory space is for all the other elements also, but this memory space size will be 5 bytes because this is having the highest requirement. This member having the highest requirement. So this is the use of union, and same way we can access union variables. Okay. Now the last one, the enumerated data types, enum or enumerated data type. That is very interesting. So I hope you have done switch case. I have not covered the switch case. This is very interesting. Instead of nested if else, we can use switch case. But remember, switch case having some limitations. And number one limitation is only constant integer values can be compared. Now you will say, why sir, why only constant integer values? See, when we write the switch case, we write it like this. This is our choice variable. And see how I am writing the case variables. I am writing the case variables 1, then something, break, then case 2, colon, break, like this. Correct? Now these are the values which will be compared with the value of ch. So actually we are in case 1, it means whether ch is equal to 1 or not. Have you ever used any floating value in this position like this? No. Why not floating value is used? Because I already shown you that in case of floating comparison, there will be some limitation. I have shown you now. If I write it this, will this one execute or else part execute? Suppose x is already 0.2. So I have shown you that it will execute the no part, else part, not this yes part. Because there is some memory means truncation problem in case of floating numbers. That's why float numbers are never used. Have you ever used any string to compare? No. But we can use character. Why we can use character? Because character having some ASCII value. That's why only constant integer values are assumed or used in this case values. Have you ever used any variable here? Try it. Whether it will give you error or not. It will give you error. Variable cannot be compared here. Only constant integer values. So these are the limitation of switch case. So floating numbers are never used in case of switch case. But string can be used. Means how means application. Suppose I want to check whether your choice is cricket or not. Suppose you have entered cricket in a string format. How can I compare it in switch case? Because switch case cannot allow you to compare the string variables. So using enumerated data types, I can compare or use switch case. How? This enumerated data type will give the string names with some values. Suppose enum, say game. Okay, then I am writing football. So it means now the football string having by default value 0. So I am converting some string in a form of integer value. Then I am writing cricket. So it means I am giving cricket the integer value 1. So in this way, I can create my enumerated data type, which will convert the string into some integer values so that we can easily use them in switch case. That is the use of enumerated data type. Okay, so with this, I am ending my structure union part. Okay, now I will give you, I have told you in the first class that I will show you what is the use of this bitwise AND. Very interesting. Bitwise and after this means now only 8 minutes is left. After 8 minutes there will be a 10 minutes break and we will meet again, and in next class we will discuss about array data structure. Okay, now the use of bitwise AND. See, this is very interesting. Suppose I am writing like this. Suppose integer a equal to 5, b equal to 2. Okay, then I'm writing if a and b printf yes, else printf no. Okay, oh, let us write it 1, then it will be better. Okay, and similarly for the same values I'm writing it like this: a and b printf yes, else printf no. Okay, now what will be the output in this case? Anyone? You can write it in chat box. What will be the output in problem 1 and what will be the output in problem 2? Try it. Yes. Yes, Snehasis, single character can be used and I have given you the answer because it has some ASCII value. Yes, Pratik, correct. First one, no, and the second one, yes. Now, why? Why first one is no? See, what is A? A is 5, na? So if I represent 5 in binary bits, it will be like this: 1, 0, 1. I am not representing other bits, those are all zeros. So if I represent B in binary form, it will be 0, 0, 0, 1. Correct? No, Pratik, you are not right. So now the bitwise AND means I am performing a bitwise AND operation. So 1 and 1, bitwise AND. So both are true, so it becomes true. Then 0, 0, false. 0, 1, false. 0, 0, false. So what is the ultimate value? It is 1. So this will give you 1. So 1 means it is true. So it will print yes. Correct? But if the value of B is 2, then see what happened. So A is 1, 0, 1, 5. And 2 means 0, 1, 0. Now if I perform a bitwise AND, so this is for 5 and this is for 2. Okay, if I perform a bitwise AND, 1, 0, false, 0, 1, false, 1, 0, false, it will give you ultimately 0. Now 0 means false, so it will go into else part. So if I use A equal to 5 and B equal to 2, in this case it will give me no. But if I use 5 and 1, it will give me yes. But in this case, both are true. This is 5, this is 2. So both are true value and get true value, true. So yes. So if I consider A equal to 5, B equal to 1, then both the cases I will get yes. Both the cases. Okay? But if I use A equal to 5, B equal to 2, then first case I will get no. In second case I will get yes. Okay, logic clear? Now see where I can use this. Very interesting. So I can use this operator to detect whether a given number is even or odd. Very interesting. Generally, we perform even odd using this operator. So question may ask that without using %d operator, check whether a given number is even or odd. So what you will do, you will take input. So scanf, I am taking input n, then I will write it like this. If n and 2, printf even, else printf odd. Check it. Suppose any number which is odd number, it should have 1 in this position at the less significant bit. Less significant bit must be 1 if it is an odd number. If you represent it in binary, it is the least significant bit. And what is in 2? The least significant bit is 0. Logic clear? So if you perform a, so is it okay or is it giving some error? Suppose it is 7. No, in case of 7 it is not giving, na? So better, so if it is 7, 1, 1, 1, then if I use, okay, sorry. Instead of 2, write it 1. Okay, write it 1 and change this one, change this one odd and this one as even. Okay, instead of 2, it is 1. So what will happen if any number is odd number, then this bit is 1, less significant bit. Other may be any value, whether 1, 0, whatever. But if I am multiplying bitwise and with 1, then this bit is 1, other bits are all 0. So if I perform a bitwise and in case of odd numbers, I will always get 1. But if the number is even, then this least significant bit is always 0, whatever the rest. But in case of 1, this bit is 1. So if you perform a bitwise AND, you will always get 0. So in case of odd number, you will get output 1. That is true. That's why if this one is satisfying, true, then I will print odd. If this was not satisfying, it will give you 0. So it will move into else part. It will print even. So this is the use of AND gate, bitwise AND, to select whether a given number is even or odd. Okay, so only few seconds are left. So we will meet again after 10 minutes.